I'm going to go ahead and record this one because I'm sure there will be a couple folks that are a little bit behind. So we'll try and make life a little easy. That way I can post it to YouTube later. All right. So you guys will have to let me know in the chat how you're doing this semester. Is everyone excited? And we got a couple more. We're expecting several more today, so it'll take them a little while to get filtering in. So as you guys are getting settled, let me know how you guys are doing at the start of the semester. You guys excited? Yeah, you guys will be into much more engineering focused classes at this point. So that's a good start. Welcome. How you doing, Caleb?
Hello. Good. How are you?
Doing well. So this will be an unusual format for the class this semester, but you guys will figure it out pretty quick.
No, I honestly like it. Like, it is a software-based class, so I think this could be really helpful.
It is. I nearly broke the university in two trying to get them to start doing this.
There we go. Right.
You guys are welcome.
Yeah. No, it seems like an awesome format, and I'm super excited.
It should be. I mean, if we're honest, you guys are going to start off sort of paying attention and then end up having to go back and look on YouTube again anyway, is usually how that goes. So by putting it there intentionally in the first place, we just sort of bypass the middlemen. So
right.
There's a lot of the stuff on YouTube is not helpful for all of this.
Right.
So it looks like a lot of you have started to get at least into the class and seen some of the things. So that's good. I'll go through the class introductions a little bit later. We're still waiting on a few more. So I'll give it a few more minutes before we get started here. I'm sure a bunch of students are trying to figure out where the TOS building is. It's going to be interesting. I'll ask somebody at the front desk. You know it's happening. So as you guys are getting settled in chat, let me know how you guys are doing. Are you excited for the semester? All right, we're getting there. Got almost everybody now. Welcome. Got a couple more. As you guys are getting settled, you'll have to let me know what you're most excited for in class this semester. All right. We've got all but a handful now, so we're doing pretty good. It's a pretty good start. there's still a few folks. I will be going ahead and recording classes. So we'll talk quickly about kind of why that is. For a few different reasons. One of which is we're going to be in a format this semester that's very different than what we've had previously. There we go. We got a couple more coming in. So as they're coming in, since all of this will be recorded, we'll talk about what's going on there. So welcome as you guys are getting settled in. Let me know in the chat how you guys are doing. A couple of you are a little surprised to see me, so that's good. Yep. They did not succeed in killing me, so the rumors of my death are greatly exaggerated. It's all right. I'm sure they'll invent something more aggressive than COVID and try again. So, all right. I think we got most everybody. We're just short a couple now. So we'll go over quickly. We will record these classes. There's Jason. We will be recording these classes. That way I can upload them to YouTube later. But again, as I've said in the welcome announcement, make sure that to get your participation points, you guys are actually here and participating. This is a class where you're going to succeed or fail based on how actively participant you are. So if you're doing the things, you're doing the exercises, you're practicing the techniques, and you're executing them, you're asking questions, you're going to do really well. If you're not, you're not going to be able to. So there'll be a couple things that you guys will be doing later in the semester. One of which is going to be, even though this is now a new format for the class, we're still going to be having you guys run the competition cars at the end. So that'll be a really fun and exciting process, where you guys are going to be able to design your own chassis, and you guys will work together in teams to be able to put these together. So this one ended up just a little bit shy of setting one of the records on account of having some limitations in the circuitry resisting power flow. So we'll talk about some of those fun things later. All right, so I think we got just about everybody. There we go. There's David. So I think we got everybody now. We'll go ahead and get started. We're going to quickly go through a couple items in the syllabus. One of the other things is make sure that you guys are, go ahead and start screen sharing here. Go ahead and make sure that you guys are working on getting listed for when we go to put up this video on the YouTube channel later. So there'll be a little bit of editing going on there. So likely you guys won't see that, but you'll have all the things in your classroom. So we'll quickly touch on what's here. So there aren't a ton of topics. Things are pretty straightforward, and for just showing up and participating in the class, you guys get like 1.5 letter grades. So make sure that you're taking full advantage of that. First steps are kind of getting familiar with the software. The reason you want to pay attention to all these little details and things that we're doing is at the end, in the later topic, we'll see there's actually an exam that you guys will be taking. So this is a what's called the CSWA. I think it's in the last topic. Maybe they've moved it around a little bit. Yeah. So CSWA, this is a SolidWorks associate certification. This is an internationally recognized certification that can actually go on your resume. And we'll talk about what it takes to pass that as we go, but you guys are going to get a lot of practice. So don't worry about those. So there's a bunch of little details here that I think you guys will appreciate. So we're going to get to know in topic 1 what SolidWorks is like, how to use it. Topic 2, we're going to get much deeper into 2 and 3D sketching, how to use some of these tools, how to fix geometric issues, things of that nature. So there's a lot that we're going to get into in terms of basic and advanced sketching. There's a bunch of tutorials that we're going to have. It looks like a bunch of assignments have actually been trimmed from this class. So when it was a 4-credit version, there were a much larger number of assignments. So here we're going to have fewer, but they're going to be a little bit more focused, which is good. So that actually is something that will benefit you guys. So there's still a number of tutorials, but they walk you through and show you where to find all of the buttons. So those are some of the things that we want to make sure that we're seeing what's actually going on for these. And I'm probably going to set up the YouTube links for this such that if you follow the links, maybe I'll put them in a playlist. I'll see. I'll think about that and let you guys know what I decide. So we will do a practice exam halfway through the semester. So expect that some of these dates are probably going to change because I'll look at some of the breaks and days that there aren't class and whatever else and make adjustment. But we have a lot of really interesting topic material. Make sure that when you guys are sending emails, you're sending it to the @my.gcu.edu. A whole bunch of reasons for that change, but we'll get into that, I'm sure, at a later time. So make sure that you guys have gone through some of this and have an idea what's going on. And then we will go ahead and jump into SolidWorks because I know some of you will still be installing, but we don't have time to waste any weeks because we have one class meeting per week. So we need to get everything out of it that we can. Any questions so far? It looks like Zach's coming back in. And I'll keep an eye on the chat as well. So if you guys are having questions coming up, there we go. If you're having questions coming up, make sure to go ahead and ask them. That way I'll get a sense of where some of the issues are. So when you first start up, it'll look something like this. If you guys are on the 2021 version still, for whatever reason, you'll want to do an uninstall and then a reinstall for this. I still need to go and install their hotfix. So on their website, you'll see the install process. So hopefully we won't have any crash issues. I'll get to do an install for that a little bit later. But what you're looking for first is a lot of times it'll come up with this home screen. So that looks like this. So what we're going to do is start with developing some parts. So what this can do is this can get us into our sketch window. So let's talk a little bit about the interface as a whole. So what you've got is you've got a bunch of different menus. I encourage you guys to kind of move stuff around and try to break the interface and then try to figure out how to fix it, how to get stuff back. You'll have things like this won't be pinned, and so you won't have some of the things that I have set up here. Sometimes this will go away or something. People like it out of their way. It's really helpful if you're using something that has a smaller screen like a Surface or anything like that. If you're trying to install this on a Chromebook, don't bother. It's a waste of time. It will not run on a Chromebook. It's just not a thing. So this is a class that's going to require kind of real hardware for things. I think they might be today. Yeah, I know they're here. I know we'll have to do what we can. So fun of running everything from home as the pest guy decided to come right during class as I have foreseen, because that's the way that things go. All right, here we go. Features and sketches. That's going to be 90% of your time is between those two tabs. There's going to be a couple of mechanics that I'm going to encourage as far as the operations. So you want to start with good discipline by understanding how to step into and out of sketches. Sometimes because of various things with at least previous versions, you had to hit sketch a couple different times. We'll see if they've fixed some of that little stuff. We don't know exactly yet. But the plane that you pick is going to be dependent on what kind of part you're going to be making. So in the assignments themselves, let's go back here and see. So on the calendar, the very first assignment, what you're going to see is down here, a lot of the times there's going to be an attachment. So you always want to scroll down to the bottom and see if there is one. What we're going to do as one of the first homeworks from this is some basic sketches. All of this stuff is 2D that you then turn into a 3D component. So 2D components that you turn into 3D. We're going to talk about how to do that. So you start by picking a plane that makes sense, and think of this as the plane that's actually bisecting whatever it is that you're working on. So if I were drawing something cylindrical like a coffee mug, right? It's one of my favorite example items to use. The symmetry of a coffee mug is along the length. And so I'm going to think about using either the front plane or the right plane, because those are planes that extend in Z the way that I want them to. A top plane can make sense for some different reasons, but it depends on what technique that we're using. Since we're going to do extrude today, I'm going to start with a top plane. So what we're going to do is create a circle. So there's all these different geometries that we can use, and each of them has a drop down for different variations. Each of these has a lot of different specific applications. We will use splines occasionally. We'll use circles, squares, and arcs frequently, like all the time. So what these are going to do is give us a lot of different mechanical options for how to represent an object. Sometimes that's with a circle. Sometimes that's with a center point rectangle. Sometimes that's with some other features, but I'm going to start with a simple circle here. So I want to make sure that circle is selected. And then I find a center point. There's a couple different ways that it'll show references. This is also really critical for most types of geometries that we're going to be using. So this is what's called a leader line, and that's giving us a reference. This white bar that'll be a little hard for you guys to see on my screen, but you'll be able to see it on yours. These leader lines give us an indication of this is horizontal, this is vertical. So these are also called snap lines, and those are things that are going to be helpful for setting geometries with specific distances when we go to do some of the harder assignments. So when it changes to yellow, that means an actual intersection point happens. So what we're going to do is add a circle, and we can then use a tool that we're going to use very often, Smart Dimension. So a lot of this, I'm going to go relatively quickly. And so you guys may have to stop and rewind and replay multiple sections of the videos in order to get things to make sense. But there's a bunch of reasons why. So 50 millimeters, I have mine as a default when I went to do the install as millimeter gram second. I'll show you real quick how to change that. Some of you will have the default, which will be IPS. You can come down here at the bottom and change this very quickly. You'll want to make sure most of the time what we're going to be doing is in metric. A lot of reasons behind that, partly because metric allows us to be very precise with dimensions and tolerancing without using something like thousandths of an inch, which is an admission that you were using the wrong length scale to begin with. So there's a difference between dimensioning these two circles that I want to go through real quick. So this is aligned with our origin, our center point, but something else that we need to pay attention to is not just the dimensions of like the diameter, for instance. So I've got these two key dimensions, and even if I were to make these exactly the same, what's interesting here is these two are not the same circles. So anybody have an idea why? Anyone have just a little bit of SolidWorks experience? Why is one blue and one's black?
Is it because they're not connected?
So not because they're not connected, but that's a good guess. That's a good starting point.
Because the black one's in the origin.
The black one is starting from the origin, which means this is something that's fully defined. A black sketch is fully defined. So it understands everything about where the object is relative to the origin. So in order to get this to understand where it is, we need to give some reference, typically a horizontal reference and a vertical reference. So here I have a vertical reference, and I can say this should be maybe 70 millimeters, but we're still not fully defined. And one of the things that we want to reference is for this one, since we are moved just a little bit, the escape key is another thing that you guys are going to want to do. Very frequently, that's going to get you in and out of tools by hitting the escape key. You can, when something is locked in a couple dimensions, you can grab it and move it. And what you're going to notice is we've set a dimension, but what has this done? It's set a dimension as a radius, right? So we have to think a little bit about how this is interacting, and sometimes moving the object will help you to see, especially when you go to do some of the more fully defined sketches and more detailed sketches we're going to do. This seems a little bit like this is not really real engineering yet, but this actually is a very, 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 very important piece of it. You can see a few different ways that we can pull off a dimensioning line. So we're going to pull this straight down instead of at a horizontal or up at an angle, because it'll let you do a few different variations. So it's very important to understand those, and we'll get to some angular and arc dimensions and other things later. What we do now is we can move objects around by setting them at the two different axes for distance. And now we have a fully defined sketch because it understands where the origin of this geometry is relative to the origin of the original geometry. So what this will do is give us most of what we need. No. Come here. You're going to be a guest star today. Come here. Up. You're going to be a guest star today. All right. So here's what we're going to work with is we are going to work with these geometries, and we're going to do a feature. So it's a good practice to do for each of these features to exit the sketch, or what I'm going to call step out of the sketch. Then you're going to see the lines change color. And because these are fully defined, it's going to make life a little easier. So we're going to do what's called an extrude. So that's one of the operations we're doing today for a bunch of different things that we're working on. You can set the geometry manually. You can drag it using this arrow when it highlights orange. You can change the direction and have it go down. So you can extrude up or down. We'll also learn how we can do extrude cuts, where we're doing cuts down through different things. So think of SolidWorks as a way of drawing and representing how you would make material. So if I were making a simple pair of table glasses or something like that, I might increase this to 55 millimeters or something of that nature. So now I have a pair of cylinders from those original objects. So this is why I selected that top plane, because if you look at, if you select any of these on the left side, this is our part tree. This is going to tell us what kind of operation what kind of operations we've been working on. We can see our top plane. This allows me to very easily make a couple cylinders in this orientation. There's another couple ways that we can do that. There's a couple other features that we can do spherical shapes with, but this is kind of the basics for an extrude. I'll show another kind of quick example where we have a little bit more complex geometry. So if I delete this because I don't need it, by right-clicking on whatever that feature is, we should have a delete feature. This might be one of the fun little hot fix issues that they're referring to. So normally you can execute a delete. Sometimes when you have the objects selected as a whole, it will prevent you. So it's interesting that we're having as many difficulties here as we are. Okay, so there's a change to the way that their feature runs there. So I'm going to start a new part real quick. So if you get stuck in that, it's going to be some sort of Groundhog Day loop where you're going to have to deselect the actual item itself. So we're going to go ahead and start a new part. Interesting. So this would appear to be, yeah, I think there's a couple of features. So definitely make sure that when you go to that SEK site, you are following along with installing that hotfix, because I think that addresses a number of these particular little peculiarities. So I'm going to do another rectangular shape. So this is a new sketch. This time I'll do it on the right plane just so that you can see how that's different. There's a few different types of geometries here. They have their place. Sometimes you want a center point rectangle. Much of the time you want a corner rectangle. Occasionally you need others, but not always. If you guys haven't ordered a mouse, that's another thing that you're definitely going to need. That's not just a good idea for this class, but it's something that you're going to need. While you're working with a trackpad, which is inferior technology for this particular class, you can come up here and you're going to make very frequent use of the view orientation button to get you to face whatever plane it was that you think you were working on. So in this case, this would be the front plane, or this would be the right plane. This would be the front plane. So this is the face that we want to see, because this allows us to be looking directly at the face of what we're actually trying to work on. So what we're going to do is we're going to add a couple concentric rectangles. So I'm going to do it this way and show you quickly kind of how to use smart dimension to make a little bit of sense of things. So this one we'll say is 50 millimeters. This one we'll say is, we'll say it's 75 millimeters. This one is going to be 50 millimeters. This one is going to be 35 millimeters. Then I'm going to set a distance. There's a number of ways to do this that are pretty fancy. But what we're going to do is just teach you the simplest example first. So you move an object around, and then you can set some dimensions equal to each other. And there's some ways that we'll learn later on how to do those sorts of techniques. But we're going to have for this about 20 millimeters as our distance. Let's do 15. That's a little bit closer. So the difference between this should be 12 and a half to get a nice even spacing. And so here, this should be about 7 and a half. So I'll let that be your homework as to why this is the way it is. Now you can see that our sketch is fully defined in all its parts based on these geometries, because this first rectangle has a point at the origin. By fixing the distance between the edges of those shapes, what we're doing is getting the program to understand exactly what it is that we're doing. The reason that it's important to set these up and make sure sketches get to be fully defined is when we go to make changes to them later, we want to make sure that that all of the rest of the relations change, especially when we want to do multiple design variations in something called a design table. So that'll be a way that you guys can really get a lot out of the geometries that you're working with without having to redraw everything constantly from scratch. So oftentimes it will default to the interior volume. You can select specific regions. So I'm going to tell you guys, pay attention often to these contours, because what they're going to do is they're going to give you the ability to say, hey, I actually really do want this specific region, but I don't want this one. So some of the time it'll default to the entire sketch, and you'll have to clear out selections and specify, I only want this thing, this part of it, right? So maybe we're going to make some kind of very simple rudimentary picture frame or something like that. And this I could do as 7.5 millimeters. And because I've got all of these set up, it's ready to extrude my feature. But one of the things I want to point out to you is sometimes, especially if you don't have a fully closed, fully defined sketch, this thin feature will pop up. So that's a warning sign that you may have done something incorrectly, or you may have some other difficulty going on. So you want to always deselect that thin feature. A whole bunch of reasons why you'll want to deselect those. But you want to really pay careful attention to the selected contours and what's being selected so that you can work with an enclosed region. When you're trying to do a complicated sketch with a lot of extrusions, you can get to run into some problems if you don't have full definition of your sketch. So it's very important to have that. So with this extruded, we can see those of you that have SolidWorks up and running. If you click and hold down the scroll wheel, you can change your view. That will be revolutionary once you actually get to work on more complicated parts to be able to see what's going on. Then you can always snap back to a specific view using the view tool. So a bunch of really, really important things that we're going to cover kind of all in a hurry for this first part. All right, so in the chat, give me an idea how many of you are currently, let me get my command bar back here. How many of you currently have SolidWorks actually running and it's up and running and it's working for you? I'll get set up for one of our next drawing techniques due. Okay, a couple of you are in the downloaded process. Good. Okay, up and running smoothly is very good to see. That's always a challenge, trying to get SolidWorks to run smoothly. No matter how much RAM you have, it's always going to tell you that you don't have enough. Yeah, Zach, you'll want to make sure that you're getting 2022 ready, because that's they allow for the newer versions to open stuff from the older version, but then it'll convert it up to a new format, and that'll create all kinds of things. Yes, technical support. There will be some conversations with technical support. The install process sometimes works smoothly for about 70% of students, and then the other 20+% suffer greatly. And then the 2 or 3% made the poor life choice of running a Mac. And often that'll have something like the ARM processor, while a cute idea and power efficient and all those other things, they can have some issues trying to run SolidWorks because of emulation problems. And so that could be what a couple of you will end up facing. Hopefully not too bad. Hopefully we'll get them squared away. Okay, good. So that's actually a lot more of you having it installed than I expected. So that's a good starting point. All right, so we're going to go over another technique. I'm still not sure why I can't do a delete of a feature. I can still do a rollback. Very interesting. So that's another technique that you can use if you need to undo something and make a change. You can do what's called a rollback by moving that line up. Sometimes that's useful. There are a couple instances where that's something that you're going to need to do. Let's do one more thing. Let's take a look at how we would create something like a ball, because that will be very, very simple. So we'll start off with a circle, because that's something that we think of as the base geometry for a ball. And a lot of times you're going to end up with something like this, where, okay, well, I can't pick a plane now. Well, now what do I do? A lot of times when you're starting a sketch, this is another thing that's really critical when you have a lot of components. So if you have a lot of other things already in the sketch window, even if they're rolled back like this, you have to expand the part tree up here and then make a reference. So here, I'm going to do it on the front plane just because that's fairly simple. So I've got a circle already selected, but you'll notice my view. If the origin doesn't look like a right angle and it looks something like this, you know that it doesn't have, and note that right angles don't go left. A lot of students kind of forget that, and so they draw stuff backwards and inverted and go to put parts together, and they don't fit because it's a mirror image. So remember, right angles go right. If you're dyslexic, that could be something you'll have to pay careful attention to. But here, what we're going to do is, again, go back to the view snap and make sure that we are square with our window of orientation. All right, so if we were to do, say, 30mm ball. Okay, so this, we have a cool technique under the features here called Revolve. And they show an example of something like a donut. They also show this little animation deal here where you can make a disc out of a rectangle. So we can make a ball into a sphere, right? But then you see here, we need some kind of an axis of revolution. Okay, well, this gets us into another type of reference thing that we need in some drawings. So we can't do this yet. We're going to hit the red X and cancel. So we're going to go back into this sketch. If we were out of the sketch and we had the light blue, what we could do is we could either click. So if you click and hold over the name, you can rename it. You can always go to edit sketch here. You can also right click and edit sketch. So that tends to be my habit for a range of reasons, so that I know I'm editing the specific sketch. The reason this becomes important is when you start adding in lots of reference planes for some features and techniques we'll learn about later, you need to know exactly which plane and which sketch you're working on so that you don't get things mixed up. So you'll see when we go to do things like the loft feature, why that's so critically important. So to take this and create it into a sphere, we need something called a center line. Now, what we can do is use this leader line or this reference line technique, and that orange highlight tells us it's going through the center. Anytime you're doing a line geometry, it's going to connect stuff until you tell it to stop. So you have to hit the escape key in order to get off of it. So then you can still use Control Z, which is your friend, unless you're working on assemblies, in which case try not to use Control Z because it will ruin your life on the CSWA exam, unless you know what you're doing. All right, this now gives us a fully defined line. What's interesting is because we didn't specify with smart dimensions, even though we put in exactly how big we wanted it to be, without smart dimensioning, it's not going to automatically use a fully defined sketch. So we'll say this is 60 millimeters. Now we're going to do something cruel and use another tool, but we'll do that actually in a couple minutes after we do this quick demo. So once we're done, typically for whatever operation that we're doing, we're going to hit the check mark, or we're going to hit the escape key depending on what it is that we're trying to do. So I'm going to go ahead and step out of this sketch by hitting exit up here. And then I'm going to go back to this revolve because we now have something to revolve. So again, notice, hey, I don't know what I'm doing. Sometimes you'll be able to click on the feature. But if you've got a lot of stuff going on in the same sketch window, I want you to get in the habit of expanding this part tree every time you see this box and finding what it is that you're looking for. So here we want to manipulate sketch 2. So it's going to make a couple assumptions, and line 1 is what we're going to be using. You can manually define this. So in a simple geometry like this, it's going to make a correct assumption. And because it's a fully defined circle, we're going to be able to do a revolve, and this will work, even doing a blind revolve. If we only wanted it to do a certain length, we could do something like 275. All right. So this would give us just the narrow range. You'll notice the way that it treats some of these. So let's take a look at, for instance, just, let's do just 35 degrees. So 35 degrees, very different. So you can see where it starts from this plane. So again, our origin relative to that reference plane, this is the back, and so this is the front plane. So if we're looking at the front plane, we see what our sketch looks like. This is that original circle that we started with. So as we go back up to 360 degrees, it's going to start from that, and it's going to rotate. If you're looking on from the top, it'll rotate clockwise. That is going to get confusing later on when we have more complicated geometries, but for now, we'll go ahead and leave it. So, but even still, what we're going to see is, wait a minute, the sketch is open and self-intersecting, or it intersects the center line. So the reason that we don't do a circle if we're going to do something like a revolve is because what this is going to try and do is create along this axis, because it's revolving the whole shape around itself, especially 360 degrees. Even if we did 180, this would work, or it should. But because of the way that this circle is going to be defined, as it goes to try and rotate around that shape, that axis is going to intersect itself multiple times, and it doesn't understand what to do with that geometry. So any ideas how to fix that? I'm going to have to go back and edit this sketch. So we're gonna have to go back and edit the sketch. Okay, I don't see any suggestions. So what we're gonna do is we're gonna use a trim feature. And I'm gonna default to trim to closest. A lot of reasons why that's the best option. But trim to closest, I think it's going to default to power trim, but you're going to want to use trim to closest, because what I can do is take away half of that circle. But now it's no longer a shaded region, right? So since it's no longer a shaded region, I have to take one more step and enclose it with a line. So the arc and this line now form a fully defined semicircle. This is something that I can use using that technique to actually revolve. So this is one that you guys are going to make a little bit more interesting use of soon. So we want to revolve around this center line. We could do 360 degrees. This is a blind region, just to show you for good practice. This is how you would select the specific contour so that it was this enclosed region. And then we hit OK, and now we have our sphere. So, but because of the way that this is created, we can see that our view is completely upside down based on what it should be. So if we look on from the side, we look on from the front. So this is actually the back plane. This is actually the front plane. So if we look on from the front, now we can see our correct view orientation. So again, I wanted to show you guys an example of where the view and the orientation matter when we're doing more complicated parts. As you guys thought we were working on the left side there, but we were actually working on the right side. So, because we were looking at it from the opposite side. So it's one of the only ways I can think to demo how you are going to start changing your thinking from 2D to 3D in how all of this works. So that covers a few of the basic processes. So those of you that have SolidWorks up and operational, I'm going to set up a couple breakout rooms for you guys to start trying to practice a couple of these things. And I'm going to jump around to the different rooms and see what some of the questions are as you guys are trying to start this process. So it looks like probably a good percentage of you, at least half or more, are in pretty good shape. So a few of you are still downloading, I'm sure, because GCU's internet is renowned to be some of the fastest in the land. That's the good news. And actually, that feature may not be enabled for this. Yeah, I think they've moved that feature out actually.
You might
So-
have to stop recording because it might not allow you to do it while you're recording.
Yeah, normally I think they've moved some of those features in the software now. So that's the bulk of the actual lesson. So I can start. I will splice these all together and then render them as a single video with things like the serial number and stuff edited out so that we don't end up with 800 million users because they'll complain. All right, so another example of this that'll be helpful for you guys. When we're trying to create a multi-component entity, so something like a silo type shape, like a grain silo or something, we can think of a couple different ways to start doing that using some of the tools that we've already done. For this one, I'm going to use a top plane, and I'm going to show you a technique for how to reuse parts of the same sketch that will save you a little bit of time down the road, but it's not necessary to do it this way. So I'm going to go to the top plane, and I'm going to set up a circle. So this one, I'll do 75 millimeter, and then give it smart dimension. 150 would be the diameter. So now I have my fully defined sketch. Because I'm going to reuse this sketch using some of the same techniques that I used elsewhere, I'm going to add a center line. I'm going to do that all the way through the center here. And what this is going to do is give me a reference point that I'm going to need. I'm also going to add this line down the center, a solid line, because this is going to give me all of the features that I need to do everything that I need to do for the next 2 steps. So one of the things that I find helpful because of how often I use them is we're going to learn really quick about a reference geometry. So I'm going to go ahead and extrude from this sketch. I'm going to tell it I actually want both this region and this region. And because of those dimensions, I want it to be something like, let's do something like 900. It's probably a little aggressive. Let's do 500. So let's do something like this. So now we have the first part. The question is, how do we now do something here? There's a couple different ways. You could start by adding a new sketch. And so I'll show you what that would look like. And then I'll kind of go back a couple steps and show you what I would do. You can click that face, or you can click that edge or some other reference point once you've done an extrude. But the problem with this is, and I'll show you kind of what that problem is, if I then create, even starting with a center line, one of the things that's easy to get into the habit of doing is sketching on an off angle like this. It's going to throw you off, and it's a bad habit to get into. So you want to reset your view. Just trust me, I'm a doctor. So I'm going to use an arc. I'm going to use a 3-point arc specifically, or a center point arc. It's different from a 3-point. I use 3-point and center point often. So this gives me just this arc that I'm interested in. I'm trying to show as many different variations of technique as possible so that you guys can kind of adapt and adopt different techniques. So because this is referencing an extrusion from a fully defined sketch, this arc itself is already fully defined. So if I step out of the line properties there, I have a fully defined semicircle at the top, right? And this works great. I can then step out. I can do my revolve feature, and I only need 180 degrees here. And then we're done, right? But then I go back and read the assignment prompt, and actually this isn't supposed to be this tall. That looks nothing like what the actual prompt does. That's way too tall. So I had to fix it. And now this is where the problem can originate, depending on how complicated and detailed your sketch is. So instead of editing the sketch itself, because the sketch is fine, I have to right click and then edit the feature. So it's another thing you're going to do very often. So actually this needed to be 450 millimeters. So this time, because I'm referencing the top of that geometry, it was able to follow. Depending on what it is that you're doing, you can create a problem. So I'll show you what, or I'll show you an example of what that looks like using this next technique. So I'm actually going to delete the Revolve, assuming it'll actually let me delete a feature. No, it will not. Interesting. Yeah, that is a bug with a capital B. So I'm hoping that's fixed in the patch, because I need to go back and reinstall that. Yeah, you normally can do that. So I'm going to do this a different way now. So one of the toolbars that I make visible all the time, and it's going to be under view and toolbars. This is also where you can come back and find the command manager. If for some reason this top ribbon that's called the command manager goes away, this is where you can find that again, because a couple of you will almost certainly have that happen, and it will send you into a full-blown panic. Reference geometry is one that I recommend having. I stick mine off to the left side just because that tends to work really well with the way that I think about the program. The way to do that manually is to insert a reference geometry and then plane. I don't want to go through those 8 steps every single time, especially for complex geometries. So in this case, it's very simple. I'm going to reference that face, or and this is what's going to create the different dimensioning that I'm talking about, and it'll create an error. So I'm trying to intentionally create an error so you guys know what it looks like, so that when it comes up, it will be obvious what you need to be doing. So if this was, let's say we'll set this back up at the 500 millimeter distance right here. This is what's called a reference plane, and we're going to get to use these very, 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 very often. So this is going to be something that's going to benefit you here really starting in the next couple of weeks as we start getting further into 3D sketches. But there's a lot of utility for these that we'll get into. So I'm going to start by fixing this. I'm going to set this back to the 500 that we had. And now on that plane, I'm going to add a sketch. So when you select a specific plane, this is what I was talking about you really want to pay attention to which one you're selecting. Because if you just do a sketch, it may or may not default to being on that plane. But this will allow me to separate the features of this sketch from this cylinder. There are circumstances where you do want to be able to do that. It's not always exactly the same reasoning, but I'm going to go ahead and use my center line again, deselect the tool with escape, and then I'm going to come back here to a center point arc, because that just makes the most sense. Again, realign things, because the center point of that line is not the same as the center point of the origin. And if you're trying to do things quickly, you're just going to whip it like this. So a number of you are going to do this on sketches. So I'm going to go ahead and leave the error so that you know what it looks like and where it comes from. So if you're trying to be quick and lazy and you go, all right, I'm going to connect this. Almost every semester, at least one student turns in something very much like this. So, all right, now I'm going to go back over to features and I'm going to revolve because I just want to get done with my homework for the week. 180. All right. There we go. So now I've got not quite close, but not quite. Now I go back, do the same thing, figure out, oh, wait, this actually isn't the right aspect ratio. This actually needs to be 400. Now we have a problem, right? So is there a way we can fix this? Or do we just have to start over? What do you guys think? Let me see a vote in the chat. How many think we can fix this? Good. Positive attitude is good. Yep, totally fixable. The reason I like reference planes is because I can come back and any of these features that I'm working on, I can come back and edit and say, actually, I really needed this instead of the top plane. I really needed this to either reference this face with a 0 offset or reference this top plane and then have the new dimension entered as 450. Much of the time, if instead you associate it with the face instead and do a 0 offset, that will get you what you want and the geometries will move together most of the time, including the reference planes. So those tend to be pretty important. So this gives you a few ideas on how to fix some of this. The other thing is we want to know, how about this top part since we messed that up? What do you guys think? Can we fix that or do we need to start over with a new arc? Let me know in the chat. Is it easier to start over or do you think we can fix it? Okay. So we've got a few mixed votes. A lot of folks very sure that we have to restart because it's ruined. Can't go back. Okay. So what we can do is we can expand whatever that feature is and look at the base sketch that created it. There's a reason it's good to have some different sketches for different types of features that you're executing. We can go back and edit that base sketch. So here, instead, what we can do is we can actually cheat and use Smart Dimension to fix it. So what I'm going to do is I'm going to grab that center point and say the distance between that and the origin, midpoint 1 and the origin. It's not wanting to let me grab this. So let me see if I can highlight it a little differently here. You can also do it here. If I select, so if I selected the center line, set up the Smart Dimension, you can sometimes force its hand by saying manually expanding the part tree. If there's geometry in the way and it's not allowing you to make a selection, here again, the reason it's confused, this is actually a really good example. Because I didn't do a reset, the actual origin is here, even though it looks like my origin should be here. So this is another example where the view orientation is important. So now I can actually pick the origin. But if I'm struggling, I can always expand the part tree and manually reference the origin as my second dimension. And this I want to set as 0. So that will relocate my geometry to the center. And here it actually fixed the geometry to do the one thing that I needed it to. When you get to be more complicated geometries with more intersections, more tie lines, more intersecting geometries, that won't always work as cleanly, but it's a starting point to correct where that feature is located. So now, if I rotate this and step out of the sketch, you can watch it rebuild correctly. So there we were able to fix the geometry without having to do really extensive surgery. And one smart dimension is a whole lot faster than going back and starting over, right? So these are all kinds of the dozens of little nuggets that I'm trying to plant kind of early in the semester so that you guys can start working to be time efficient in your sketches. Because that's one of the main things that I want out of the semester for you guys, is making sure that you're efficient, that you're fast, that you understand when I throw at you any kind of a drawing that has dimensions on it, especially when they're far, far more complicated than these, that you guys know how to deal with each and every one of them. Because there's a couple different things that we need to know, even starting out early in the semester, like R standing for radius, the circle with the slash through it standing for the diameter or the distance across the circle. There's different heights. There's reference measurements if it's a broken line and all of those sorts of things. So we'll get into more detail about these as the semester goes along. So this gives us at least a good range to start with for some of these early techniques. And a lot of the times what we're going to do is, as far as like the format of the class, we're going to start off by covering some of these techniques. We've already covered a number of the really, really early ones. But we're going to cover the use of a technique. We're going to apply it to a couple different parts and geometries. Then we're going to turn around and have you guys practice and drill. Because you're only going to learn so much by going back and watching the technique that I'm doing. The mastery of this class comes from you guys actually doing the practice, doing the repetition. So that's one of the main things that we want to spend a lot of time doing this semester. All right. So that covers, I think, the major techniques for this first part. There's a couple other things that you guys are going to need to access. So let's go ahead and go over that as well. Let's get an update on your downloads. Are a couple of you still stuck on that process? I'm hoping a few more of you are able to follow along now. That's why I wanted you guys to start downloading the instant you got access to the welcome announcement, just to give you the best chance of getting the most done. So I'll keep an eye out for that while I set this up. So there's a couple different things that we'll use later in the semester, but one of the ones that I want you guys to be in the habit of is there are a number of files and models and things like that. But there's also a series of tutorials, and there's a few different things over here that you can access. There's a couple resources. There's like a SolidWorks manual, some other components. There's appearance stuff that we'll learn about how to deal with a little bit later. But this is really kind of the hard way to get to things. So instead, what we're going to do is we're going to go back to the home tab, because a couple of you are going to start looking for some of these assignments In particular, you're going to start looking for anything that has a tutorial on it. So even like this sketching basics assignment, you have a few dimensions that you're going to be working with. So we're getting a little bit more complicated, some more references and things. So we're going to advance the technique next week of how to really do a lot with the smart dimensions. But all of these tutorials are going to really kind of help as you guys get this installed, kind of get you functional in the software. So I'll show you where to find them because these don't have a document attached. And we'll talk also about some of the mechanics of how to submit an assignment. So that'll be fairly straightforward, but it's something that we want to keep in mind. So let's do this. So we go back to the home tab, and then there is up here on their list of options, there's learn. So the step-by-step tutorials, this is what we're looking for. And it's going to open up this other window. So this is what we're going to see. And all of those tutorials, many of them are going to be under the basic techniques. So this is the introduction to SolidWorks one. So this is one of the first ones. You're also going to do parts, which is here. So this is kind of the fundamentals, but most of them are going to show up here under basic techniques, or at least most of the rest of them. We'll do some, I think, of the advanced techniques. We're not necessarily getting into mold design and some of those other things at this point. I don't think we do a lot with the productivity, but there are some things that we do with simulation. I think a lot of that's now moved into individual classes. So I think there may still be one that we're doing there. And then there's some CSWA prep type processes. So giving you a more complicated geometry with more features, and it'll walk you through how to do each of these. So a bunch of these are actually baked into the assignments. So I'll go ahead and terrify all of you guys with this one, the French curve. So this is what we're trying to build you up to, because if I can get you to survive the shock of opening a drawing like this and actually understanding what this means, which you guys will, then anything that they put in front of you in order to create for the CSWA exam, these are the kinds of things that they're going to be, that are going to prep you the best to be able to take that exam on with confidence. So this is why we're paying attention to all these little nitpicky details that seem like they're not very fun. It's so that we can start to get to do really fancy things later on down the road. But all of these, the pattern features, the parts, all of that is here. Mostly under either the basic techniques or the CSWA prep. So I think half or 3/4 of them are CSWA prep. So what they'll do, we'll take a look at the intro and what this does. Let me make sure that it's actually going to show the geometry. So this may be a couple of the other things. So we don't actually need any of our other geometry there. You use navigation buttons going forward and backward. They don't really have them clearly labeled. But what you can do is when you click these, it will actually show you in the software again. For whatever particular reason, we're having some challenges. I'll get that patch installed because it's doing a bunch of very unusual things. But what this will do is it'll highlight and show you where in the actual software these things are. So a couple features that you've already seen. and it'll walk you through how to use smart dimensions, how to create a couple of these processes. Some of the time, there'll be a couple questions that'll come up, especially here where you're trying to do a distance between them, an offset distance. So that's one of the features that I was working with. You can use the offset entities, and it'll show you where that is. So it'll kind of introduce you to a lot of the features that allow you to get some interesting parts very, very quickly. And we'll get into a little bit about creating holes and starting to create things that are looking more and more and more like actual parts for things. It'll show you how to do a simple fillet, etc. And then it'll show you how to do a couple quick examples of patterns once you've gotten a feature in order to get to a final part. Another piece of wisdom that I will share with you guys is make sure that you are saving early, saving often. Here I'm not doing that, but SolidWorks is renowned for its ability to crash your computer. So you want to make sure that you're saving early and saving often. And occasionally those tutorials and things will ask for where a couple part files are. You'll have to open them. So I'll show you real quick in the directory where those happen. Actually get this guy moved. Here we go. So starting from something like your desktop, what you're going to want to do is you're going to want to go to like your hard drive, and then users, and then public documents. SolidWorks 22, and there's these example files specifically for the tutorials. So most everything that you're going to need to access is going to be in there. Maybe not 100% of them will be. There are a couple that I think come under the simulation rather than the tutorial, but you'll get an idea. So they're all here, they all exist, but this is where you're going to have to go to find them. So under users, public documents, and then SolidWorks. That's one of the other ones that generates many hundreds of questions per semester. All right. So I'll pause that here. So we just talked a little bit about the extrude cut being very similar to the extrude, similar kind of features. And sometimes you need a blind cut for a certain depth. Sometimes you need a through all cut. If you have multiple different geometries involved, you might need a through all both, which means through all both directions, essentially infinitely. But a lot of times you'll be okay with blind or through all. You can draft inward, or you can draft outward, depending on what type of operation you're trying to do. You can do a second direction cut. Most of the time I don't recommend that, but you want to make sure that you are very carefully selecting which specific contours you want to be doing the extrude cut with. Another example of using that through cut for something like this that maybe has an unusual shape. There's a couple more steps that you need for reference geometry. So this is a useful thing to see for a reference plane. What you'll need is, again, to expand the part tree and start with something like a bisecting plane, which in this case is the right plane. And then you can use as a second reference point something like an edge this way. and you want it to be instead of perpendicular, you want it to be sometimes you want it to be coincident. But you can also use, depending on what you're looking for, you can have it be a specified distance away. So if you pre-select what you want it to be, so in this case, a distance of, if we set that to 0, that would set it to a distance of 0. So that would be a reference plane on the right plane. Now, with that 0 offset, if we were to select this edge, the distance doesn't work for us anymore. So we have to reset this to being parallel to that plane. Now that frees up our geometry to be able to be attached to the edge of whatever this feature is. And we're going to be able to do some more complicated stuff more quickly here. This now, we can change our view orientation to make sure that we're looking squarely at the part. We'll do another quick example of a cut extrude. And we'll do, yeah, we'll do, I'll do a polygon so that you guys can see what that looks like as well. Before I do that, I'm going to add a center line, and it's going to look for what plane we're doing this sketch on. So I'm going to expand the part tree and tell it I need to be sketching on plane 2 so that it doesn't get confused on what's going on. So that center line is still selected. I'm going to use this as a reference because our polygons have a center point. So I'm going to do one here. And I'm going to come back in with the trim. And I don't need most of the rest of this. I'm going to do a fairly simple type of pattern. So I'm going to come back in with lines. And here I can use that yellow highlight changes to where I see the additional yellow dotted line. That means that this line is parallel to this line. So I'm going to do the same thing here. I'm going to see this is parallel. And then the circle inside the circle means that those points are concentric. And some of the same things you're going to see in the tutorial are this linear sketch pattern. So what we can do is we can select this. We can do it along the X, the Y, or the Z. The X axis is not actually particularly helpful for us here. So we're going to say 0 in the X axis. And what we're interested in is this one, which is looking at our values here. That's the Y axis. So I'm going to go back into the linear sketch pattern. So this, we only need 1. The Y, we actually want to do 3. 10 millimeters is fine. And then we want to select the entities to pattern. What we're going to do is select this whole region. And we're going to separate this. Okay. Looks like Tyler's going to be back. So we're going to separate this by a distance of, let's see what 100 millimeters looks like. Since way too far. So let's do 20 millimeters, something like that. All right. So here we have our randomly chosen shape. And now we can do an extrude cut using these. And this will be a good example for a way to show you how to do another instance of a through all. So I'm going to go to features while I have that sketch still selected, because that's the one that I want to do this operation with. So this feature, and right now it's going to try and do a cut this direction. So what I'm going to do is you can either hit here, flip the side to cut, or change the direction manually, which is going to make the most sense. And so here, by doing select through all from this sketch plane, I can now see all the way through the part that I've got going on. And now we can see what we have as far as a geometry. So it allows us to have a lot of really interesting kinds of features and characteristics in the stuff that we're doing. We'll learn later in the tutorials about how to do lofting and some fancy shapes like this, but you guys will at least be able to kind of play around with some of these techniques and start getting very, very far into how to create some of these drawings very quickly. So I'm kind of going over 2 to 3 weeks of techniques at a 30,000 foot overview. So that's why it's going to feel really, really fast and aggressive. But that's a good way to begin in order to make sure that you guys have a very high pass rate at the CSWA, because that's going to be my goal. I want to make sure that there's no question as to whether or not this particular class format can work fine in order to get you guys to the goal, which is that CSWA exam. Okay, so we've been able to use that particular feature. I'm going to pause here and then check in to see where further questions are coming up. All right, so I'll include this part as well. What we want to focus on as far as the mechanics of assignment turn in, there's a few things that I want to see from you guys. One of the first big things is making sure that your part tree is expanded here. That way I can see what techniques you guys are using as you go to create things. I tend to have, for a whole range of different reasons, the snipping tool down in my toolbar all the time. This allows me to come in and do a lot of different notation. So what I want to make sure that you guys are doing is submitting Word docs. We'll see how much they've fixed about Halo. But I'm going to take a screenshot like this so that I capture my my full part tree, and then make sure I'm capturing at least, or trying to capture, what year it is. It's always interesting to see what kind of odd hours of the morning, Sunday morning, or really more accurately Sunday night, Monday morning, students are turning stuff in. That's private entertainment for a lot of the faculty members a lot of the times. What we want to do is we want to be able to highlight what's been done. This way I get to see what's happening here in all of these, and you don't have to actually outline any of them. I just want to make sure that you're actually using these techniques properly, and make sure that you understand how to apply them. Sometimes for certain things, you're going to be able to select a portion of the part and bring up dimensions. It's not always going to bring up clean dimensions for every single thing that you're going to be working on. It's probably easier in some of the other example parts that we had, but you're going to be trying to get it to show some of the key dimensions if you're able to. So here, this is 100 millimeters. So you can only get there by selecting part of the parts themselves. and you're going to take some screenshots with a couple different views showing what it is that you've got, what dimensions you can get it to show, so that we know you're being dimensionally accurate with these parts. So in this case, the plane, the loft operation itself, any of those will give kind of that key fundamental dimension for length. There's other notation and things that you can add to them, but they don't really help for this circumstance. We're not going to get into drawings and things like that yet and how to create those from parts. But we do want to see what these key dimensions are for some of the parts you're working on. So you'll take a snip of that and also add it into the Word doc. So you'll generate a new one. Go. It's a blank Word doc. And you'll paste in a number of these screenshots showing the key dimensions. You want to make sure to do things like add your name, class section, date. Those are all helpful bits of information to make sure that you know what assignment it is, what month it is. A couple months in, you're probably going to start losing track. That's okay. That's why we want to try and capture it where possible here. So you'll add in all of your comments. They're also, for most of these assignments, the way that they're written, you're going to see not for sketching basics, for instance, but for something like these tutorials. Reading comprehension is a very important skill in college, as it turns out. So making sure to pay attention to describing why this was included, and then what the, how you would plan to use this content. Think of different applications where that might help you represent a geometry of a real object. We'll get into more and more detail because we actually have an example of a practical part I'll show you guys here in a few minutes. That's one of the projects that I need to do. So we're going to work on it as a class exercise. I'll turn it into a drawing and then have you guys recreate it. I'm going to throw the real part on the 3D scanner and see if I can get a 3D mesh recreated for it and do some cool stuff for comparisons and see if we can have a little fun with the dimensions. But we'll get to that a little bit later. So we want to pay attention to what is going on here, making sure we're answering those questions, because if you look at the rubric, it'll show you kind of what the criteria are, but note that the purpose questions have points associated. So a lot of students have lost easily a half letter grade just from the purpose questions not being answered. So make sure that you're paying attention, reading whether or not those are there, and submitting things with full view screenshots so that I know what you're doing and I know where some of the difficulties, challenges, and struggles are coming up, or if there's techniques where you guys are really hurting on. There might be a time where we can go back and focus on one of those, but we'll see, because the class time is actually pretty sharply limited. All right, so as you guys are working on these, what questions are coming up? I think there's one other thing that I needed to note for this one. One of the other things that I need you guys to do, I will end up probably, for the sake of record keeping, one of the easiest things I can have you do is attach to your discussion forum. Go ahead and reply to yourself for a reply to your own post. Once you've added in your introduction, go ahead and reply. If you have completed these two as the prerequisites. So a couple of you have had me for that. Probably most of you have been through this, but this is the only two prerequisites. So make sure to note that you've fulfilled the prerequisites. Then that way we can make sure you guys are not missing things because there's no way in the system for them to catch whether or not you've actually taken the prerequisites, as silly as that is. So yes, the smart dimension, that's actually a good question. So once something is already in a 3D format, if we say, okay, wait a minute, maybe, so on this part, I can go over this plane. So let's edit this feature. So in this one, in order to change something with smart dimensions, what I'm going to do is I'm going to have to edit either a feature or an object. So I'll show you one example of each. Let me throw this back on. Yeah, okay. So this is still recording. I wanted to double check. Yeah, so this, let's do an example of each here. So what we can do is we can go in and edit the actual feature. So we'll start by looking at that. This one, we can come in here and say, we'll have to edit when we're editing a feature. We can edit it here, say 120 millimeters. And then hit the check mark and it will stretch out our part to accommodate it. Another example is you'll have to expand the operation, whatever that particular feature was. You go back to either sketch 1 or sketch 2. So we'll take a look at sketch 1 since that has a complex operation associated with it. And maybe this we had all wrong, and maybe we didn't need this inner circle or something like that, or maybe it was the wrong dimensions. So we'll actually set some dimensions here. So say 45, and we'll say 80. All right. So this allows us to change the dimensions of that base sketch and make corrections. So then we can hit escape to get out of that tool. And then we step out of the sketch by hitting exit. And that will get us to this new version of the geometry. So another question, submitting drawings, including all the metric. So yes, you can take screenshots with the views. You can also take a look at some of the isometric views. So one of the good ones might be something like that. You still want to try and show some of the key geometry. So here, now that I have dimensions associated, this would be a good example of the kind of screenshot that I'm looking for, because this will show the key dimensions for that exterior. So here, if we were to go back and edit this base sketch again and say this was smaller, maybe that was a feature we were planning on implementing later, let's say 55, and we'll do it off to this side. 25. So maybe this was a feature we were planning on implementing at a later version of the part or something like that. So we're going to step out of that tool. Then we're going to step out of that sketch And now when we go to collect this, more of our dimensions show up. So some of the time, dimensions will show up. A lot of times, if you just have something like a cylindrical reference, or you don't have a lot of detail in the geometry, and it's not fully defined, you'll be missing most of those details. So this is another thing that kind of helps us to know whether or not your sketches are fully detailed, because you'll kind of want to show usually 1 or 2 steps in the process. So you'll want to show something like, so I'm going to cancel this and I'm going to save it real quick. So if we took out that feature, took away the reference plane, took away the cut extrude, you can't go all the way back up to just one of the sketches. You can only go up to the feature level. So you would show something like this as one step. Then you might show the addition of these 2 planes. And then you might show the cut extrude as your final step. So the objective is to be able to demonstrate what your process was to get to the end result and make it clear that you know how you got there and how you could repeat it. But using something like an isometric view makes that a whole lot easier. Whereas if you're doing something like this and you grab that feature, you can kind of see what's going on with dimensions, but you got to use your imagination pretty hard. So isometric is a good call for most things. Okay. I'll go ahead and pause the recording here.